Right, I hope that you noticed that this equation here, the systems here, is exactly the same here. And what we wanted you to do is to look at kind of our options of how to solve it, and then also what it is that the solutions mean algebraically. So for this one here, I can see that if I multiply this through by a -2, meaning the combination method, and then add these together, that will cancel, leaving me with a -8y, and then this will cancel, leaving me with a 0. So when I divide by a -8, I get that y is equal to 0. Well, that's what I had last time up here, so that seems to work out pretty well again. And then I just need to plug that into either one, so we'll plug it into the bottom since it looks nicer. So x is equal to 3. And sure enough, that's exactly what it is. So this is algebraic, this is graphical, and then this is the point that is really the solution. Let's go ahead and look how this one is a little bit different. If you notice, this is the same thing on this as well. So let's look at what that means algebraically. So I'm going to go ahead and multiply through by -2 here. And I'm going to carefully do that. So I make sure all my signs are the right ones. And then I'm going to add them together. Cancel, cancel, cancel. Now don't go crazy. If you start canceling everything, just double check. Make sure that they really all do cancel before moving on. So this is 0 equals 0. In other words, this must have equaled this in order for it to be 0 equals 0. And that's what our solution looks like graphically. So I used combination method on this one as well. And again, this is infinite number of solutions. Let's go ahead and look at one other situation that you end up with, and that's here. Now, for this one, it's kind of already moved over a little bit, so I might go ahead and use substitution. Get y by itself. Y is equal to 2x minus 4. Again, since it's just so easy to get it that way. And then I would substitute in, instead of writing a y, I write what y is equal to. So I'll say that again. Instead of writing this y, I said, well, y is all this mess. So I put all that mess into that spot right there. So now we just need to simplify. Now, those guys cancel. You end up getting -12 is equal to -18. And that is not true. It's not equal. And so this doesn't work. And what would happen is if I would look at this, basically what I have is some parallel lines that I'm looking at. And so there is no solution that works for both of them. So algebraically, you just need to know if you get something that's not true, it's no solution. Whereas if everything cancels each other out and 0 does equal 0, then that means it's an infinite number of solutions.